Okay, so sorry. An alarm went off on my phone when I was making the video, and when the alarm went off, the recording shut off. And so it stopped, and that was a really long video. I'm not going to go back and remake it to get this all together, so this is just going to be a two-part video. So sorry for the problem. Technology is great when it works, but it's really frustrating when it doesn't. So anyway, that's what happened, and that's why this video is in two parts. So sorry about that. Okay, so here's the critical point. This is where we were, number 34. I plug it in and I get a z value, so I'm going to highlight it to save it for when I go to compare values. All right, so here's the way I set up my lines. Again, you can do this any way you want to, but it'll be easier for you to follow along when you try this problem on your own, which I'm going to have you do in a second, if you label them the same way as me. So I did line 1 here, line 2, line 3, line 4. Okay, so what I want you to do now is I want you to pause the video and I want you to try this by yourself. So what I would do is I would pause it, try line 1, start the video again, watch me do line 1, and then pause it, try line 2, watch it, check your answer, so like that. So, start the video back again every line to check. Okay, so pause the video now, try line 1. All right, so hopefully you've tried line 1. Let's look at it here. Here's the, I'll show you all of the work so you can check your answers while I talk about it. But so all the points on line 1 were where y was 3. If you look here, that was line 1 where y is 3. So you go through and you replace all of your y's with 3's. You get this function and the bounds on the x were 0 to 5. So you find the critical number, which was 3/2. Again, the y is still 0. So you're plugging it in here for the x. And you get, is that a 4? Yeah, 27 over 4. So that would be the critical number. All right, now for the endpoints, you have x is 0 and x is 5. So you're plugging those in, where to go? Again, here. And that would be your z values on the endpoint. So again, highlight them so you can find them. Okay, so that's line 1. So now pause the video, try line 2. All right, so line 2, all the points on line 2, if you look at the graph, line 2 was this one. So here the x is always 5 and the y is between -3 and 3. So you should have replaced all of your x's with 5s. And you get this, which is again a function of a single variable, so it's a Cal A problem. Find the critical number, it's -5/2. Plug it in here, and that gives you this z value, so highlight it so you can find it. And then for the endpoints, for 5, -3, you get -11. But for 5, 3, if you remember from line 1, let me find that page. Yeah, line 1, I already had that, so I don't highlight it again because I already have it. So that was a repeat. All right, so line 3, try this one, pause the video, try it by yourself, and then come back. So line 3, everything on line 3, y was -3. It becomes this equation, x is between 0 and 5. Find my critical numbers, plug it in to get my z, do my endpoints. This one is a repeat from line 2. And the reason why, again, that you're getting the repeats is when you're doing the endpoints. We're doing the endpoints, you're doing the corners. So see for line 1, whoops, which one was line 1? Hold on, just kidding. Line 1 was the top one. Okay, when you're doing line 1, this corner, you're going to get it again for line 2. And then when you do line 3, that corner, you already had it from line 2. You're going to get it again on line 3. So see, that's why there's so much repeat, because it's these corners. Okay, so line 3, you get those 2 points. And then lastly, so pause the video and try line 4. All right, so line 4, all the x's were 0, so it just becomes this. The critical number is just 0, so I have 0, 0. Endpoints, I already had both of those, and now I'm going to compare. So this is where it's handy to have highlighted them as you go. Okay, so if you highlighted them as you go, this is the one from step 1, that was my interior. These are all of my ones from step 2, these are my boundary ones. I want the smallest and the biggest. So notice this one, you might have thought these were the smallest. This is -11 and 1/4. So this one's actually smaller. So this is the smallest one. This is the biggest one. And so here they are as decimals, if that helps. So this would be my absolute max and min. All right. So just if you want it, here are some notes if you want more details. Okay. So I'll try to remember to post this on Angel. If I forget, somebody send me an email and remind me, but I'll just go ahead and show this to you here. You can kind of make your own notes or screenshot it or whatever. hold on. I don't know if I can get the whole thing. Is that the whole thing? Yeah, I don't know if that's helpful being turned this way. But anyway, so it's just kind of step by step for the absolute max and min problems. So here's for the interior, that's the part 1. Okay, that's what you're going to do first, that part 1. And then for the boundary, each line has 2 parts. So line 1, you have 2 parts. And then you would repeat those same parts for line 2 and line 3 and however many lines you have. And then the last step, compare. So that's what we've been doing. It's just a little bit more detail, if that helps. Sometimes people get lost in the steps because they're so long. So anyway, sorry about the 2-part video issue with this one. But that is all from 3.7. And there's also one more section, not 3.7, 13.7. That's all from 13.7. There's one more section in chapter 13, but that's not on the list of stuff that we have to cover. So we're not doing 13.8. So this is the last video from chapter 13. So if you have any questions, just send me an email.